Hello. I received some questions about some IXL problems. The three are right here. So we take a look here. It says select all the expressions that are equivalent to 7 over 18, 7 to the 18th power over 7 to the negative 2 power. Because it does say select all, so there's a high chance that there are multiple possible answers here. The first thing I notice about this problem is that it is a division problem. This is 7 to the 18th power divided by 7 to the negative 2 power. And since this is a division problem and we have like bases, then that means we can subtract the exponents. To try that out first, so I'll take the top one minus the bottom one, keeping the 7. Our base does not change. A double negative here means we'll end up adding 18 plus 2. So let's see if 7 to the 20th power is on here, and yes, it is. Now, it did say select all, so let's look very carefully. I'm not really sure. We look at 16 and I think, okay, well the only way they could have gotten 16 is if they had done 18 just minus 2. But that's not what we do here. We do 18 minus negative 2. So this can't not be an answer. And then look at this one right here. 1 over 7 to the negative 20th power. This is actually our other answer as well. So whenever we're dealing with negative exponents, you can kind of think of it as the reciprocal exponent. It flips the fraction and changes the sign of your exponent. So basically in this one, they made it unhappy. These are equivalent. So this is our second answer. And the last one here cannot possibly be one of our answers. I'm not sure where 9 would come from, unless maybe they divided. I think that's what happened. So this would be incorrect. They probably did 18 divided by negative 2, and that's how they got negative 9. That's probably the mistake there they were expecting you to make. So it's not that one. So do pay attention to the fact that it says select all of the expressions. So you may have said the first one, the 7 to the 20th power, and had not selected 1 over 7 to the negative 20th power. Second problem here, select all the expressions. Once again, select all. We have 3 to the 6th power times 5 to the 6th power. So this one is interesting because it's wanting you to, they're like, where'd the 15 come from? Well, since these both have the same exponent, we can actually rewrite this as 3 times 5 to the 6th power. This is called the power of a product. And this was one of the properties that I put in your reference sheet towards the bottom of the page. So I would look at the reference sheet for properties of exponents that I shared with y'all for this one. Also, there were plenty of YouTube links and stuff, so if you want to see more powers of a product, I would look at that YouTube link I linked in the reference sheet. So using the power of a product, I was able to rewrite this, since they have the same exponent, as 3 times 5 to the 6th power, which would make this 15 to the 6th power. So this is our answer. And none of the rest of these are going to work. It can't be this one, right? Because they added the exponents on this one. But whenever we add exponents, they have to have the same base. These do not have the same base. 3 and 5 are not the same. If I were to expand this out, I would have 6 3s and 6 5s. Okay? Those are not the same number. I am not going to rewrite this as 15 to the 12th power. These have different bases. I still only have 6 3s and 6 5s. I don't have 12 15s. In fact, if we could regroup this and do them in pairs, I could think of this as 3 times 5, and then 3 times 5, and then 3 times 5, and just kind of repeat this, doing them in pairs. 3 times 5, and then 3 times 5. And then notice then that 3 times 5 is 15, I'm going to have 6 15s here. 15 times 15 times 15 times 15 times 15 and times 15. Now I have 15 to the 6th power. It cannot be that one. It's not going to be 1 over 15 to the 16th power, 6th power, because there are no negative exponents here. If that was 1 over 15 to the negative 6th power, we could do that for the same reason up here that I was able to do the 7. And 36, I guess they did 6 times 6 here. That's what they're saying. They're trying to say 3, they did 3 times 15, 3 times 5 and got 15. Let me ask you again, do you see 36 15s here? No, there are only 6 15s, so it cannot be that one. So this is a case where the select all could be a little deceitful for you if you don't understand what you're doing. So if you want to write it all out in expanded form and then regroup things, then that's how you could wind up with 15 to the 6th power. All right, this example. Select all the expressions that are equivalent to 2 to the 7th power risen to the negative 2 power. So this would be a power to a power, which was another one of those properties at the bottom of the reference sheet I sent you, power to a power. So this is going to be, whenever you have a power to a power, you just multiply. So this would be 7 times negative 2. So it'll be 2 to the negative 14th power. Well, that's this one right here. Okay, and since we have a negative exponent, it is unhappy. We can use the negative exponent property and rewrite this as 1 over 2 to the positive 14th power. Notice how I kept the 2, it's still 2, but now my exponent is positive because it's happy, it likes its location. So negative exponent doesn't like where it lives. We flip it, the reciprocal, 2 over positive, 1 over 2 to the positive 14 would be this one. It can't be that one because it was negative on the top and positive on the bottom. And 2 to the 5th power, I'm guessing they thought you were going to do 2 plus negative 2, which would have given you 5, but that's not how you do that. I hope this video is helpful, and y'all send me more questions, all right?